Okay, so what have we got here? So I've got 2 down and 6, step 2, question 2. So using the series e to the x equals to 1 blah blah blah, well that's just a Taylor expansion of e to the x, right? So show that e is greater than 8 over 3. Okay, well, because you have e, right? You have e itself, and the series is e to the x. So I mean, what is a sensible substitution to make, let's say? Right, a sensible substitution to make is x equals to 1, right? So e equals to 1 plus 1 plus 1 over 2 factorial, 1 over 3 factorial, plus 1 over 4 factorial, blah, blah. Okay, let's try to evaluate it, right? Step questions is all about trying, okay? Always try things. Don't sit there and just look and then think. Okay, well, I mean, I think not that thinking is bad, but, you know, you have to try. So, well, let's say I do this. Well, I suppose I could evaluate the factorials. You know, it's not the hardest thing to do. Okay, well next I've got 5 over 2. Oh no, how do I get 8 over 3? Oh no, and you start to panic, right? You start to panic. And then what happens is that something really brilliant happens. So what happens in front? This is 15 plus 1. This is what? This is the 8 over 3 I want. And what can I say about the terms after it? All of them are positive, right? It's just 1 over something factorial. Nothing is negative. Yeah, all of the terms in the expansion of e to the x are all pluses anyhow. So e is larger than 8 over 3. Job done. Okay, so don't give up halfway, please. Alright. So, next bit. Show that. And, n factorial is greater than 2 to the n for n greater or equal to 4, and hence show that e is less than 67 over 24. Okay, well, let's try that, shall we? So, let's erase this to make space. So if I want to show something for like n greater than a certain number, what do? What is the common technique? Is obviously induction, isn't it, right? Classic technique. So, base case. Okay, I'm just going to do very sketchy induction, okay? You write it in a very formal way, please, okay? Base case n equals to 4. Well, obviously 4 factorial is greater than 2 to the 4, right? Because, why did I write n? So this is 24 greater than 16. Okay, good. So that is fine. Now, consider the n plus 1 case, right? So n plus 1 factorial is obviously bigger than 2 to n plus 1, right? Because n plus 1 is greater than 2 for n is greater or equal to 4, right? That's obviously a really sketchy proof, right? But you get the idea. Yeah? So n plus 1 is greater than 2. Because the left hand side I multiply by n plus 1. The right hand side I multiplied by n. Yeah? By 2, sorry. Yeah? And none of the numbers are negative, right? So I don't change the sign of the inequality. So because n plus 1 is greater than 2, for n greater or equal to 4, so the inequality still holds. Okay? And hence show that e is less than 67 over 24. Okay, how do you do that? Again, don't give up, right? You just have to try. So let's start. So e equals to, now I'm going to do the same thing because essentially I want e again, right? So I sub in x is 1. Maybe I'll go one more term. Or maybe I should keep the factorials actually. Yeah, let's keep the factorials. 4 factorial plus 5 factorial, and so on. Okay. So, I have to prove that e is smaller than something. E is smaller than something. Okay, so what should we do? What do we think? Well, we have a 24 here, right? We have a 24 here, so maybe we will keep this term. I don't know if we will keep it, but it seems like we should keep it. So, let's try to do this. So I want this now to be a smaller sequence. So what can I do? I have to make the right hand side bigger. Now, I know that 2 to the n is less than n factorial for n greater or equal to 4, right? So what I can do is I can do this. 4 factorial, I could write it as 2 to the 4. Right? What if I do this? What if I do this? That's valid, right? That makes the right hand side bigger. Because, 16 is less than 24. So the fraction is larger, essentially. Yeah, and I do the same, 2 to the 5 plus 2 to the 6, plus blah blah blah, until infinity, right? And what is this? What is the rest here? Just a geometric series, sum to infinity, right? We definitely know that. Good. So, one sec, let me erase this. So this is equivalent to, well, we know that one was 8 over 3 from previously, right? So that's 8 over 3 plus 1 over 8. Yeah, the geometric series here evaluates to 1 over 8. By the way, that should be equals, okay? That should be equals. All right, we only need the smaller or equal to, no, we need the smaller than symbol in one line only, okay? And that equals to, well, common denominator, 64 plus 3, which is indeed 67 over 24. Yeah, so that is proved. Lovely question. Okay, so last bit. Last bit is, I don't know why people hate the last bit. The last bit is quite pretty actually. Show that the curve of the equation, that thing, has a minimum turning point between x equals 1/2 and x equals to 1. Okay, how do I show something has a minimum? Well, a minimum looks something like this, right? I mean, to be generic. So, firstly, x equals to 1/2 would probably be something of negative gradient, right? Negative gradient. And x equals to 1 maybe is a positive gradient. If I could show that, then I definitely know that there's a minimum turning point, right? Now, technically, that is really not rigorous, all right? In like calculus and analysis in general. Okay, but you know, it's just a step question, right? We're not quite in university yet, so let's just take it for now. Okay, so let's see what's happening. Let's try to differentiate the thing, shall we? Differentiate the y before we do anything. So differentiate the y prime. Okay, y prime equals to 6 e to the 2x plus. Oh, how do I differentiate this? This is really ugly. Minus 14 over 4 on 3 minus x, I suppose. Yeah, something along those lines. Okay, so essentially that equals to 6 e to the 2x plus, let's make this look nice. So this is 42 over 4x minus 4. No, 3x minus 4, my bad. 3x minus 4. Okay, lovely, good. So I want to prove that there's a change of sign in the gradient, right? So I plug in x equals to 1/2, and well, you will be able to prove that you get something which is less than 0, yeah. And x equals to 1, that will be something greater than 0. Okay, just trust me on that. You could just compare the values of e and compare the values of the fraction. Okay, I'll do it. All right, why not? Okay, so you just go x is 1/2, right? If you go x is 1/2, then what do you get? You get 6e plus, what is it? Plus 42 over minus 5 on 2, is it? Is it? Yeah, okay. And you know that e is capped at 67 over 24, right? So this thing is capped at whatever. How do I do this? So 67 over 4 minus 84 over 5. And you know this is a negative number, right? This is a negative number because that's 20 something. This is, I don't know, 16 point something, right? So it's capped by a negative number. So the value has to be negative. Okay, so that's how you do it. All right, and for x equals to 1 is equivalent, right? It's bounded below by something positive. So the expression has to be positive. Okay, you could do that yourselves, I'm sure. Okay, good. So, and give a sketch to show the shape of the curve. Lovely. So how do we do that? So let's think about how the curve looks like. First thing is that it's less than 4 over 3, right? Because it can't go over 4 over 3. If it goes over, then the ln has something negative in it, and you're in trouble. So that's no good. Now, what do we think about when we draw graphs? Well, firstly is that you use the information equation, I suppose. And you think about what it does when it tends towards infinity. Okay? So, now, we don't have to consider positive infinity this time, right? Because it's bounded at 4 over 3 anyhow. How about negative infinity? What happens? So, this becomes 0. But the last bit becomes infinitely big, positive infinity. So the graph probably starts somewhere here. somewhere, in massive distance. Okay. All right. And think about what happens to gradient at infinity as well. If I have minus infinity in this expression, the whole thing is 0 actually, really, right? So it's probably flat when it's going to infinity. It's probably flat. Okay, it's tending to a flat line. Okay. Now, what is the y-intercept of the thing? If I chuck in x is 0, I know that this is 3 plus 14 ln 4 and 3, I suppose. I don't think that's really important, but might as well, yeah. And label it axes, I suppose. Good. Now, what happens when x gets close to 4 and 3? So this gets ridiculously small, right? This thing tends to minus infinity. So I suppose let me draw this properly. So it probably does something like this, right? It's tending towards negative infinity when it goes to 4 and 3. Okay, and what happens at the x-intercept? Well, I don't know, right? There's no way I'm putting that equation y equals 0 and I'm solving it. There's no way, okay? I'm just going to make some estimation. All right, so I know there's the minimum at 1/2 and 1. So if I connect the dots, it's probably something like maybe this, maybe it hits somewhere there and then does that. Yeah, maybe like that. Something along these lines. I guess you could make better sketches than myself, I suppose. But it's probably something like this. How do I do this? Like that? Like that? Yeah, okay, I can't have okay, this one's wrong actually. I can't do a good drawing, but essentially it should be flat when it's minus infinity. It does something like this, and it hits some sort of minimum between that. Okay, maybe the minimum's not there, maybe it's here, I don't know. It goes back up, and at some point it drops down. Okay, now the question didn't tell us to calculate the maximum, so I really don't care where the maximum is. And I really don't care where the point intersects the x-axis, because the question didn't tell us to find it. And obviously there's no way I could find it, right? Unless I'm some, Wolfram Alpha or something. So there we go. I think that sketch is good enough. All right, so go on Desmos and actually try to look at how the curve looks like. All right, it's probably something similar to this. Right. And yeah, and then you start to have a feeling of how different graphs look like. And that would help with your sketching in general. Yeah? So every time you see a graph question, do actually go Wolfram Alpha or Desmos to actually search for the curve for step questions. Yeah, or after you have done it yourself, obviously. Okay, so it's quite a nice question. Good.